Welcome to my video where I want to go over the Popular Astronomy magazine, April 1937. I'm going to look through it and show you some of the highlights and some stuff I noticed, talk a little bit about it. There's a cool telescope you could buy there. I'm sure that was expensive at the day. All right, one of the things I noticed as I opened this up was the nebula in Andromeda. So there's a picture of Andromeda. That's an exposure of 12 hours. And then this is a 9-hour exposure of the Orion Nebula. And those of you who've done much astrophotography, you know we can do this with small telescopes now in a fraction of that time. So let's just show you this was done by hand, basically hand tracking, and rather involved. Also the word nebula. Okay, in the 1920s, they pretty much, thanks to Edwin Hubble, they determined that these galaxies, they were galaxies essentially outside our Milky Way galaxy. So that was a debate, but this terminology, nebula, continued up until probably the 1940s at some point. So it's an old terminology, but they had, by this point, due to the Cepheid variables, determined that there were external galaxies. And if you want to know more about Edwin Hubble, I have a book on him on Amazon. And so I'm just going to flip through this. There's a lot of writing. It's definitely a lot different than the modern, like Sky and Telescope. This magazine started in 1893 and went up to 1951. I guess it terminated with the death of the main editor. The distance to the greatest nebula, Andromeda, the nearest extragalactic nebula, 900,000 light years. I think it's about 2 million now. I'm not sure. I think it's about 2 million light years, I think is the current estimate. The distance to Andromeda from us. Let's see, so here's, like I said, not a lot of pictures. Oh, meteors and meteorites and meteor showers are important. Here's Jupiter. Okay, this says, working at the Western Union College in Alliance, Ohio, with a 10-inch refractor, the author and his coworkers, blah, blah, blah. But the idea is a 10-inch refractor. I've never looked at a refractor that big. That would be pretty impressive looking at Jupiter. I bet you can see some good views. I don't know what the biggest refractor is, probably 5-6 inch that I've looked through. Let's see more about Jupiter, the planets, talking about the nearest stars, meteors, meteor showers. There's one picture I wanted to show you. Again, they start talking a bit more, estimating the velocity of the meteors as they come into the Earth's atmosphere. Trying to do that from basic geometry. Oh, and here is a rotating meteor spectrograph with 4 prism cameras. So this is a camera system that's got a spectrograph built in, so it determines the breakup of the light. Okay, and here's a spectra right here that they apparently took with that camera. And it shows you there's a little star, and so there's a streaking of the meteor through the sky. And let's see, I think they determined it has some calcium in there. Yeah, calcium and sodium. And they found some other stuff in there. It kind of gives a breakdown of the wavelengths, kind of with their best guesstimate of what they think is in there. Manganese, and so here's another one. This is on a variable star. This is a nova from 1936. And then I did notice one name here somewhere, Leon Campbell. He was a big name early on in the American Association of Variable Stars, AAVSO. I remember his name from when I was more active in that organization. Let's see, what else we got in here? Oh yeah, here's some comet pictures. Now you can see here they would track on the comet. That's why the stars appeared to be trailing, because they were tracking on the head of the comet to get the comet picture. And this is the Wilk Peltier. This Leslie Peltier was a big astronomer back then. I think he was an amateur actually. But he discovered quite a bit of stuff and was real active. And then here is Comet Whipple. And this goes back to Fred Whipple from the dirty snowball theory of comets that he came out with. So that's he's plotting the orbit of the comet. They're real good at plotting the orbits of comets. They weren't exactly sure what they were yet. Let's see what else we got here. I highlighted a few things in here as I kind of read through this. Oh, here's one thing. But what causes the star to collapse? The simplest theory is that the star experiences a temporary famine in energy, available energy, called the substance whose change supplies this energy X. It may well differ from star to star. It must have a short life, downward slope, and the light curve would be more gradual. Okay, this goes back to before we understood nuclear fission and fusion. And they came up with actually how stars were formed just a few years right after this book in the late 30s, early 40s. And so you can see they didn't understand nuclear fission and fusion at that time, which is the main power of stars. So it was, they just had some early theories of what was going on about the stars. And here, this is the, which got the indexes on the back, but table of contents. These are some of the, okay, here's the Norton Star Atlas. I've got a couple of these already, not from 1937 edition, but I wish I did. More modern version. That's a good star atlas to have. Every amateur astronomer should have one. Oh, here's a cool telescope here. And now this is a microphotometer. What they did was they didn't have digital images, so they would take photographic images and use this densometer to try to figure out the size of star, their diameter, and the density on the photographic plate. And from that, they would try to determine the photometric magnitude. And so this was an early way of doing it. Pretty inaccurate, but it does give you some information on how they did variable star work off of photographic plates. And all that star map you could order. Alvin Clark and Sons Company, they were kind of some of the premier telescope makers of that day. And then here's a cool telescope on the back, apparently made by this J.W. Feck company. Again, so this is the Harvard College, Oak Ridge Station, Harvard College Observatory at Cambridge. So that was the big reflector telescope there, and that electric drive down here, equatorial. That's pretty neat. Well, hope you learned a little bit about the history of astronomy and what was going on in 1937. And thank you for watching. And also, give me some comments if you got some feedback or questions. You know, I'd always like to hear what you're thinking. Thank you. Bye.